Hey everybody, I'm Daniel, and today we're taking a look at a pretty awesome robotic arm right here on the Game of Knowing. So I'm super excited to be finally sharing this project with you after about 2 months of working on it and tweeting about it. I actually built the first revision before I was able to start filming, and so I wasn't totally sure how to start documenting, but I decided no better time than the present. I'm going to bring you guys on board now, talk about the project, what I'm hoping to do with it, and then I'll make more frequent videos in the coming weeks and months as it progresses. That's what I'm going to be showing you today. Okay, so before we do a little demo, I just want to show you the mechanics of how this thing actually works. I designed this whole thing. It was actually my very first design ever in Fusion, which was quite a bit of a learning experience, but a lot of fun. So the basis of the whole thing is this steel cable, which goes down the center and is held by shaft collars. I know it's not necessarily the right thing to use, but I don't have a crimper, at every point. So on both sides of each sort of vertebra, if you will, there's a shaft collar which keeps them all in the right positions. I also have these little Ninja Flex sleeves around that cable, which makes it look a little bit nicer, keeps it from kinking, and also just sort of gives this whole thing a little bit of resistance so that it comes back to center to some extent. Then the actual motion is controlled by these pieces of paracord. As you can see, when I pull on one of those pieces, the whole arm moves in that direction. Those are controlled at the bottom by two spools. So the pieces of paracord on opposite sides of the robot are both on the same spool. I tried them with individual spools, but the motors just did not have enough torque. So when this moves this way, as you can see, this gives out more paracord, and we can actually see the spools moving down below. As I move that, you can see it spinning. And then that is connected to two stepper motors, one on each side, and there's the same sort of system in the other direction of motion as well. I don't think you can see that other spool quite as well. But yeah, that's sort of the theory of operation. I'm planning to add perhaps some sensors or other things on top. I've redesigned very slightly these plastic pieces so that they'll have mounting holes, so I can add lights or sensors, whatever it is I want to add in the future. The really neat thing about this design is that the failure mode is the motor slipping. If I were to have this try and move something that was too heavy, or if it got stuck, the motors would just slip. There's not really all that much pressure or force on any of the plastic pieces, which is pretty great, and I think a big improvement over more hard-bodied, in many cases geared ARM designs. So now we come to the brains of the operation, the electronics box I've designed, and there are sort of 3 layers to this thing, so I'll just take you through them one by one. At the very bottom, you can just see the ports for this, is an Adafruit Metro, which is an Arduino Uno clone. It works fantastic. It's just what I happen to have on hand, and it has most of the I/O that I need for this. Right above that is a prototyping shield on which I have 2 things. One is a buck converter to reduce the 24 volts that powers the steppers and the motor controllers down to 5 volts, so I don't have to have a separate power supply for the Arduino and other logic. And then there's also a Adafruit UART Bluetooth module, which is super nice. I don't have this implemented quite yet, but I'm eventually hoping to be able to control this thing wirelessly. Right now I'm just doing it over serial, and it's not a huge leap to then translate that to Bluetooth, but I just want to make sure that I don't have to have this thing tethered eventually. And then finally, we have the motor drivers. Each motor is independently driven by, I believe it's a DRV8255 motor driver, and those are each sourcing 2 amps of current at 24 volts, which is a ton. That could eventually be a problem because even with heat sinks and this big 24 volt fan that I have on there, 60 millimeter, those things are still getting super hot. But for right now, it's what this project needs, and it's working. And then finally, we have just our big power supply. It's a 24 volt supply, and I'm trying to base the whole project off of 24 volts, which was sort of forced by the torque requirements. I tried 12, just did not work with these motors. And that's about where the project is for right now. I'm super excited about it, but as you can see, it's still pretty early. There's no acceleration, the motions are still pretty jerky, and I'm still hitting individual keys to get it to move every few steps. So the future holds a lot, hopefully, for this project. First, I'd like to start open sourcing this thing. That's been my plan from the beginning, and I've just sort of been in a place where the files weren't neat enough. I didn't really want to put it out in a way that people couldn't use. So I want to start getting those files up on GitHub and Thingiverse. As I mentioned, I've designed pretty much the whole thing and written the code myself, and what I haven't written is based on open source. So I should be able to get all of this out there so that you could even build along with me if you want. And also, I want to add acceleration to the motor driver that I've written. I already have some ideas for that. I don't want it to be too fancy, but I want it to be able to move more smoothly. If I add sensors or other things on there, I want it to be able to manage that weight. I want to implement the Bluetooth module that I already have on there. As I mentioned, it's a UART module, and I'm already using Serial to control the thing, so that shouldn't be too much work. Finally, for now at least, I want to add in some things to make this look a little bit nicer and to sort of show sort of the beauty of the more organic motion that I think this platform really has. I think that's one of the coolest things about it, is that it can move very smoothly in any direction. It is kind of like a tentacle, so it almost looks like it could just come to life right in front of you. So I'm planning to add neopixels, or rings of neopixels, which are red, green, and blue LEDs that can do really cool patterns on each level of the robot. So then I'll be able to do some cool animations, maybe get it moving in kind of an organic way, and I just think it'll be sort of a cool demo of a first thing that it can do. As part of that, I'm actually going to need to add I'm just going to call it a coprocessor. So I'm going to add another microcontroller that'll be connected to the first, also over Serial, so that I can have more I/O and do those sort of things like LEDs or computer vision, or control a hand on the end of it or whatever, or a grasper, without having to worry about the timing or messing up my motor move. I want the arm itself to be rock solid, and then anything else I add just sort of be extra on top of that, if you will. So that about wraps it up for right now. I'm really excited to keep you all posted on those things that I've just mentioned, and even more as the project continues to develop. If you have any of your own ideas as to what I should do with this, or improvements you think that I might want to make, please let me know down in the comments. I'd love to see those. Also, if you want to start building your own, I will post in the description links to those files. It may not be up right away, but check. I will get those to you so that you can start developing or building on this yourself. It's a really cool platform, and I want this to be able to make as much impact in the community as possible. I'm excited to see what you could do with this too. So leave a comment, check out the files, and I'll see you next time right here on the Game of Knowing.